My name's Blair Layton, and I'm the Business Development Manager for our database services across Asia Pacific. I've actually been with Amazon now for almost 3 years, which makes me almost part of the furniture. I'm one of the older people in the office. So what we're going to talk about today is how you can scale your applications for large promotions and events. So without further ado, what is a large-scale event? Everyone's definition can actually be different. So let's try and give examples and tell you what it was all about. So fundamentally, it's an event where you're going to need more capacity than you normally would. Typically, for a short period of time, could be an hour, could be a couple of days, could be also a couple of weeks. But normally, you're doing a promotion or an event for a period of time, and after that's finished, then your capacity needs to come down again. So these also are often associated with a number of large users coming into this particular application during that promotion event. And that means that it's really hard to architect that solution well and to be able to provide the infrastructure associated with it. And if it goes badly, customers get very, very angry. Okay? So think about an iPhone launch. One of the telcos here in Singapore does a launch, everyone gets excited, wants to go and get their phones. If you can't get into the system and you can't apply for the phone, you're going to get very angry customers. If there's a weather event, and this one here is for Taiwan, anyone from Taiwan? Well, yeah, a couple of people. Very sorry about all the typhoons there. But obviously, when it happens, a lot of people do go to the websites to constantly check, where is the storm? Where is it tracking? What are the latest warnings? What's happening with the weather? So when the event comes along, then they're obviously tracking that over the time of the storm, and the website needs to be able to perform and scale as that comes and passes by. Anyone play this? All right. So the Clash of Clans also runs on AWS. Now you can imagine, it doesn't matter whether it's obviously Clash of Clans or any other gaming platform, if you're going to send out a lot of notifications to everybody's devices and say, hey, there's a promotion right now, if you come in, we'll give you a gem or a coin or something like that. And of course, everybody gets notification at the same time and they all come into the game. So that is a very, very difficult problem to deal with as well. Ticketing. In this case, we've got some, maybe the Chinese pop star, Kanto pop star, who knows, who wants to come around, is very popular, and everybody wants to get the tickets for that. So again, similar to the phone launch, you've got a window where everyone's going to come in and try and get these tickets, reserve them for the concert. But for you, it could be simply just needing a bit more capacity, maybe double capacity for a particular event that you're doing. It could be an e-commerce promotion, could be a ticketing thing, or maybe it's just month-end processing, right, or quarter-end. So everyone's event, for large-scale events, is different, but the fundamentals of what we're going to go through are the same. So if you look at the problems that we face, when you're looking at trying to solve this, how do you know what the infrastructure requirements are? How many users are you going to get? If you're talking to marketing, they're going to say, yeah, we're going to do really well. But what happens if you go and buy all that equipment and then you only end up using a small amount of that? And it's only for a short period of time. So because it is for a short period of time, it's hard to sometimes justify even doing these promotions because of the amount of kit that you're going to have to go out and purchase. The legacy system integration is also important. Often if you're doing financial transactions, you're going to actually have to integrate with, say, a bank or a payment system, and perhaps you've got ERP systems that you need to put orders into on site. Are they going to be able to handle the load, and how do you manage that? Then understanding the system behavior and the metrics. If you're going to do this on a fairly regular basis, you need to understand how the users are accessing the system, how you can help adjust the flow and fan out users, and also just measure where there are bottlenecks inside the application system. So getting the right architecture for this is actually quite difficult if you haven't had experience in this area before and this is the first time starting this out. And associated with that is finding the right talent. So let's go through and see what happens when it goes wrong. So this was an article from an Australian news site back in 2014. And Jetstar had just gone out to do some promotions of $88 fares to Bali, and their websites melted down. So many, many people, of course, then took to Twitter, and this is the type of feedback that you get. So this one is my favorite here. The amount of hate going down on the Jetstar website right now is gold. You get what you pay for. Ha, ha, ha. All right? You don't want this to happen to you. All right? So if you realize, okay, we've got this problem, we don't want to end up in these types of situations, what are we going to do? And the first question is always constant. How are we going to scale, especially the database? Yeah? A lot of you probably already were familiar with AWS. Oh, they've got the auto-scaling stuff, we're good. But then you get down to the database tier and it's like, oh dear, what are we going to do here? So now let's get into the architectures and how we go and build these types of applications. So starting from day one, where you're going to build this system, you've got one user, which is you. And you're developing this, so you've got yourself going through into an Amazon infrastructure with a single server, and you put everything on that EC2 instance from a development perspective, and it's great, works for you. But when you want to start adding more users, what do you do? Well, the first thing you say is, I'm going to need a bigger box, all right? And we've got plenty of bigger boxes, and we can go up quite a long way, something like an R3 8X large, where you've got 32 virtual CPUs, say around 256 gigs of RAM, and that's some pretty serious processing power. But you are going to hit a limit, and there is not going to be a bigger box until we get to the next stage. So we are introducing X1 instances, which have been announced, and they're going to have up to, say, 2 terabytes of RAM. So you can see that we are continually improving and introducing new boxes, but you're still going to be at that limit. You're always going to need more. And of course, there are problems with this as well. No failover, no redundancy, and everything's in the one place. So if one thing goes wrong, it breaks the whole lot. So what we want to do then is start splitting things out. So on the second day, we are going to then say, all right, database instance is now separate, and the web instance is also separate. So this gives you a lot more scale, right? The database now has a dedicated instance, and the web tier has a dedicated instance. It will actually be slower, because previously, everything was operating on the one box. There was no network trip that had to happen between the web tier and the database tier. So now you're going to have a slower application, but a much more scalable application. Then we have to decide what is the right database for the job. MongoDB fanboys? All right, few people, cool. So at this point, some people go, yeah, I want to use the new stuff. We're going to go with MongoDB or DynamoDB on Amazon or Cassandra or something like that, Couchbase. Just start fresh, do everything new. That is not necessarily the right approach, especially if the skill sets that you have are traditionally in, say, Oracle, SQL Server, or general relational technology. Don't force people to learn something that's new. Also, if you're going to be doing transactional type behavior in your application, relational databases are still the best for that. So, decide wisely and look for the key points of scale where there might be problems with a relational system to use NoSQL where it's appropriate. So once we get past that and we've decided that, okay, in this case we're going to use RDS, Relational Database Service from Amazon, we put MySQL on there, and we've now got a master instance. That makes life easier, right? Because we don't have to worry about deploying it, backing it up, recovering it if something goes wrong. If the underlying server goes bad, Amazon will replace that. It becomes much easier. So that's, over 100 users. When we get to over 1,000, now we want a bit of redundancy, we want a bit of more scale, and we want to make sure that we're building up an architecture that's going to take us a bit further. So now what we've done is we've taken a standby database here on a different availability zone. We put the web tier across 2 availability zones. So these are the orange dotted lines. You can think of them as data centers. They're physically groupings of data centers, but you can think of them as a single data center. At the top there, we've got a load balancer. So now, as the users come in, they get balanced across these availability zones. And then if something does go wrong with an availability zone, that will then fail everything over to the other one. Okay? So now you're getting a very scalable, resilient platform. Once we get to the next level, Now we've gone crazy. We've got a lot more happening with auto-scaling, perhaps, or you may not have to do it yet. You can also add read replicas, and we can do this with MySQL, MariaDB, Postgres, and our own database, Aurora. So you can now easily scale up reads and take away the bottleneck on the master database and leave that for writes, and perhaps where you've got read consistent operations that you need to ensure are there as well. The next one we need to look at is say, well, hey, this is pretty good, you know. This is going to get us quite far, and many customers come to us with an architecture like that, and they're quite happy with it. But there's a lot we can do when we start looking at the platform that AWS offers and taking advantage of more of the platform. So what is that? Well, if we look at some of the other services we have, we've got Amazon S3, where we can actually offload some of our static content, such as HTML, JavaScript files, image files, and so forth, and then we can deliver that through Amazon CloudFront. Now, this is quite surprising, and many customers find this, is when they offload the static content, and even some of the dynamic content to CloudFront and S3, the size of the middle tier servers and the number of them drops dramatically, because they turn into mainly application servers now, not just the web tier serving out a lot of the web traffic. And that really helps you scale. Not only that, of course, CloudFront, if you're running this, say, from Oregon, we have a point of presence in Singapore, we have a point of presence in Manila, in Taiwan and other places. That means that their content's going to get cached. So if you're doing something globally, we have over 50 points of presence around the world, you're going to get all that scalability of the Amazon network to deliver that closer to your customers. Now, looking at the Elasticache here, what can we do with that? And DynamoDB. Let's say you're doing something with session information, and it's transient, it's not that important, but you need to keep track of that. You don't want to keep writing that into the database, because that's going to increase a huge amount of writes on the relational system. But you could put it in memory in either Redis or Memcache, and then you get huge scale of in-memory operations, and you can constantly refer to that, update that object, and it helps scale immensely. The other thing is, if it is perhaps session or login user management information, which is critical, so it must be durable, you can use something like DynamoDB, which when you store the information in that, it's located in 3 physically separate data centers on different SSDs. So highly durable service, highly available. Now, when you're doing that, again, you're taking this component here, let's say it's user management, and making that highly scalable. You can say, I want this for promotion to go up to this level, and then after the promotion, I want to drop the performance back down to that. So you only pay for what you want during that time. Whereas with a relational system, if you want to change the capacity, you can do it, but you are going to suffer an outage of about 60 to 90 seconds as you change the size. So you get a bit more flexibility to do these things if you start choosing different databases for different jobs. So this is pretty good now. Once we've moved to this architecture, I would say this is fairly optimal. Right? You're going to do a pretty decent job here. You're going to be able to scale to over 500,000, say, users. So this is a very good setup. But now, once we get to this point, what can we actually do? And the next stage is often one that people are sitting in the audience going, must be some magic Amazon service to do this. So this is not an Amazon service. This is all about architecture. And often I ask the audience, and people are still thinking, no, it must be something magical for Amazon. It's not. What we want to do at this point is make radical changes. And to do that, we are going to start adopting SOA, start looking at services, components, microservices, etc., and breaking the application up. Now, why is this important? Well, if you think about a traditional application where you've got tight coupling, you have a controller A feeding into controller B. Now, they are tied together, right? If it was a bottleneck on A, then B is sitting there not doing anything. So what we want to be able to do is scale those components independently and allow them to be loosely coupled by adding a queue structure. So this could be SQS, our simple queuing service, could be Kinesis, you could use Redis pub sub, anything that's going to help you separate out the different components of your application and scale them independently. So now if we look at what the architecture can be used for, you can then say, well, we've got internal applications here, which were part of the monolithic application before, but have now been separated out. So when you want to do your internal reporting, see what's happening in the application, that's now going to be operating off separate components versus being part of the overall application. Also, we've got worker instances here. So they're reading things off a queue and then processing that and scaling that work as it needs to be. Now, the best example I think everybody can relate to, who's uploaded a video to YouTube? Yeah, most people, okay. So when you upload a video to YouTube, you send the file and you put in the metadata, the title, description, put some tags in and all that kind of stuff. And then it says once it's uploaded that it's now processing that file. But you can save that metadata and then you can go away and do something else, and it can notify you when it has finished processing the file. Because let's say you upload a 1080p HD video, then it's going to have to do the 720p, it's going to have to do the 480p and the 360 and so forth. All of that takes time, right? So they have a similar thing where there are worker instances doing that transcoding, and that is happening separate from the main application, where you can continue to say, upload another video or go and watch another video while that's all happening in the background. So that's the way I think I can relate, hopefully, to you of what the benefits are of starting to decouple things and adopting a SOA-based approach. So this really is going to get you a very, very long way, and this is what Amazon does a lot inside Amazon.com as well as inside AWS. So the next big steps after this, if you're going to go from 1 million users, and now we're going to start looking at, say, 5 to 10 million users, this is really where you're going to start to see issues with the database, and you indeed might have already found that previously, with write contention, right? Where a database, especially if it's relational, can only take so many writes on the biggest box that we have before you are going to get a scaling issue. So the different solutions to that are you could start federating the database. By that means, if you think of a website where we have a forum database, e-commerce store, and the general database for the website. Each of those are serving separate functions, so you can have separate databases for those. The next one is sharding, which everyone gets very excited about, right? Well, oh, Facebook does sharding, Twitter does sharding, we must need to shard. Do not shard, okay? You don't need that. Most of you are not going to be at that scale, and it causes a lot of problems, because what you're going to have to do is you're going to have users, I say A to D over here, and then E to I over here, and so forth, and then you're going to have to consolidate all of that data for analytics later on. So you end up creating like a big data problem where you're going to have to bring all of that together and process it on something like Hadoop, and then put it into another relational system for reporting. So don't shard unless you absolutely have to. Yeah? Last resort. Moving some functionality to other types of databases, though, is also a good thing if we're looking at a combination of like federation and so forth. And we'll have some examples of different architectures from customers to show you how they adopted that later on. You also may start coming into problems with speed of your applications and the general performance. So this is where you really need to invest in metrics to make sure that you can analyze where there are bottlenecks in your applications, track user behavior and user feedback to particular points in time, and try and correlate where that was happening. Was it a network issue? Was it a web tear? Was it a database issue? Was it something else you were doing? Because if you don't have data and you don't have those metrics, you're not going to be able to identify where the problems were. Now, especially if you're doing these large promotions, which are only for very short periods of time, then you've got to gather as much data as you can, because let's say it's an hour-long promotion. At the end of that, if you don't have the logs and customers said, oh, it didn't work, this didn't work, and that didn't work, and you've got no information, you can't try and fix that next time. So it's very important to make sure that you are logging the data that you need to analyze. So let's talk about a Singaporean gaming company. I can actually name them. They are Gumi. So you might see some videos around about Gumi and their story. And I helped them with some of their architectures and the problems they were having. Now, if we look at, for a gaming company, what are the issues that they were facing? They do promotions to a large user base playing their games and giving them offers at particular points in time. And of course, the immediate thing that happens is that when you get that notification on the phone, that you go, okay, that looks pretty good, go to the game, log in. So if you get a login storm at that point in time, then you have to be able to deal with that And the way that they were managing that is by creating the biggest RDS instances that they could to manage their promotions. But they didn't need it that big when the promotions were not happening, because the normal run rate for the games was much lower. So they adopted our recommendations in a staged approach, and I'll give you an example of the architectures and how they were built. So first of all, this was pretty much a LAMP stack. Yeah? Linux, Apache, MySQL, PHP. So here you can see, very similar to the architectures I was talking about before, where the users coming in, they can get content from CloudFront if it's cached, downloading updates to games and those types of things, and then auto-scaling groups to manage the application tier, an RDS master database, and a slave as well. So the first thing they did is to try and help scale that master database is to put a read replica. In fact, they used a series of read replicas for their architecture to help take the read load off the master database. Now, that still was having impacts in terms of the write performance on the database during promotion time. So what I suggested to them is that they use DynamoDB, our NoSQL database, and move the user management system into DynamoDB. And that was very, very successful in offloading the login storm problem into a database that can be scaled up and down when required. So especially if they knew they were going to do a promotion, they could actually set the rates on Dynamo for the tables they were using to much higher level of transactions, and then once promotion had finished and the gaming had moved down again, they could then bring that back down. And of course, they're only paying for that extra capacity for the amount of time that they're using it. The next step was to adopt Elasticache for Memcached for regularly cached items and make sure that they weren't even getting near the read replicas or to the database itself, and session information as well. And then finally, they put in Redis. Now, Redis has some great things called ordered sets. And in the ordered sets, they can do things like leaderboards. So the top 10 for this game, or the top 10 of this level, and so forth. So all of those types of things can be done easily in Redis because of that ordered sets capability. So what were the lessons learned? Listen to AWS Business Development and Solution Architects. Yes? Okay. So we provided some advice and we helped them guide that through that. And they realized that the advice we provided right at the start was based on expertise that we had with other customers and lessons that we had learned ourselves, which we were passing on to them. But they were a bit dubious and adopted it in a staged approach. But we obviously have experience with this. We've seen many customers. So if you need help, do listen to us and take our advice. Gaming promotions became much easier to handle. Unpredictable loads also became easier to handle. So sometimes the game would just take off. There'd be a lot of activity, and they honestly don't know why. Someone could have posted something online somewhere, and people got excited about it, and then they started playing the game. Then a senior operations person was able to move to another game away from one of their main games, which was causing them grief. So now everything had become more stable. So internally, it was better. And of course, the ultimate goal, the customers got a much better experience with minimal downtime and better performance. And that's what we all want. So looking at another one, local telco, can't tell you who. Sorry about that. So they do all their launches now on AWS. So the iPhone, i5s, 5C, the 6 Plus, Samsung Notes, all of that kind of stuff. When you see them launching something, it's running on our platform. They needed a system to handle a large amount of requests, okay? And they had failed at an iPhone 5 launch. So probably some of you are going, I know who that is now. But the management decided that, okay, we need to succeed at all costs. What can we do? So they came to us, and this is the architecture that we built for them. So you can see here, there is no relational database in this particular environment. So what did we actually do? We decided that for the phones and the time slots that the people are going to pick up the phone, we're going to store that information in DynamoDB. And now, actually, that's really hard, because if you think of, let's say, a Note 4, right? I have a Samsung Note 4 here. That when that launched, I think there was only 2 SKUs, yeah? 2 colors and 1 memory size at launch. So you can't just put 2 records into DynamoDB or in an in-memory system or Oracle or whatever and expect it to scale. So what we had to do is we had to create buckets inside DynamoDB with extra records so that we could make the table bigger and make it scale more with the transaction throughput. Even that was not enough, because the volume of users coming in was so high that we then had to address that with a different approach. So what we did is we had Elasticache there, 2 instances, one for the phones and the other one for the time slots to pick up the phones. So as the users were coming into the application, then we would check in the memory, are the phones and the slots still available? And if they were, we continue through the application rather than going to DynamoDB to check. So when a person got to the end of the application and allocated the phone and the time slot, we would decrement the counter in Dynamo, and if it got to 0, we would delete the record correspondingly in Elasticache. So that way, gradually, everything's being reduced, right? And then eventually there's no more left. Now, the other key point is not just the architecture of the underlying infrastructure, but also the application. So let me talk about that for a little bit. What we actually did is, instead of having a landing page where you come in, put in your NRIC or something like that, and then you get, choose your phone, choose your time slot, put all your personal information, go, we split the system up a bit. So there's a landing page when you come in, which gets served from S3 through to CloudFront. And that, if you're sitting there with a refresh because you really want to get into the system, then that's just not even getting to the application servers, right? It's just coming off CloudFront. So my manager, for the last launch of the iPhone, was sitting there with 2 browsers, right, and refreshing, using the system in the back end, because he really wanted the latest iPhone. But that means that though users like that are not even getting to this infrastructure until the point when the application becomes live, they activate it, change it, and then the first step is you do enter your NRIC, okay? Once that's been entered, then it validates that you have the right contract, that you are at the end of your contract or you don't have a contract, and you can now move on to the next phone. This was all pre-qualified, by the way, so you had to pre-register as well. So once you've done that, then the next step is, okay, please choose your phone and choose the time slot. Then after that, please put in your personal information and confirmation, and then after that, finally, summary, and that's when you get the phone. Now, by doing that process of slowing users down, because you imagine what happens. If you've got some 16-year-old girl who really wants the latest iPhone, she's going to be there, she's going to be excited, she's going to be like, brr, brr, all the way through, and she's done, right? But grandma comes in and she's adjusting her glasses while she's trying to put in her NRIC with 2 fingers. Meanwhile, the other people have all gone through. So what you've done is you've fanned the users out by changing the architecture of the application. Whereas if you put everything on one screen, it's much easier for more people to hit the database at the back end at the same point in time. So that's a really key thing. It's not just about the actual infrastructure, it's about how you design the application as well. So, what did we learn from this? They tested it with 150,000 concurrent users all coming in at the same time. Now this was for a proper test, right? So there was wait time in the way that they applied their information through the application. It wasn't just a throw everybody with no wait time in. It was proper test. All the phones were gone within 2 minutes. No misallocations or unallocated phones. Everything went very well. And then management said, that's too fast. Okay. Because what they were concerned about, and this still unfortunately happens to today, is that because the system can scale so much and the users come in, that users who are slower will unfortunately miss out on the phones. Yeah? So that's something you would perhaps think about from an application perspective of how would you change that to help with that problem. The actual launch went smoothly on the first iteration, and they have continued to use that system and improve upon it for all the other launches for the major phones as well. So that's been a great success. So lessons here. So AWS can provide the infrastructure for applications to scale with very high concurrent users. There was really a big problem when we were looking at DynamoDB as the only solution for this customer, and then we realized that we're going to need a cache. The timeframes were short. We had a managed service for Memcache, and we were able to deploy that quickly. The customer did not have to learn how to install it, how to configure it, how to make it scale. It was just a matter of putting it in and changing the code. So that was very, very powerful to leverage the AWS platform to do that. The next one, of course, was impossible for the customer to do this on-prem. Yes, they have the infrastructure and they have the capability where they could build all of that out, but fundamentally it would have been too complex and they would have used too many resources for a short period of time. So they found it much, much better to come to AWS for this. Huge cost savings as well, because they only need to start all of this for when they're doing some development, when they're doing their testing, and when the actual promotion happens. Once that's gone, they shut everything down. So you can imagine for the likes of DynamoDB, you simply say, on this particular table, we're about to have a promotion. I want to go from a handful of operations, say 5, now I want 8,000. Yep. Then DynamoDB goes and provisions that. After a few minutes, you've got rid of all the phones, everything's looking all right, great, it's gone very well. Let's give it the hour, make sure that everything goes through, there's no other problems, and then you just shut off and bring that back down to 5 again. And that's the flexibility you get by using a managed database service such as Dynamo. And of course, all the middle tier and the web tier, all the servers that you actually use, you can start them up before the promotion and you just terminate them and you don't pay for them again immediately after the promotion's finished. So even though they massively over-provision when they do these promotions, because just in case something goes wrong, it still doesn't cost that much because you're only using it for a short period of time. So looking at another customer, and this is a customer in Taiwan that I've helped architect as well, and this is a customer who sells tickets, Tixcraft. So that's a really awesome quote. With our systems on AWS, we can scale our resources more than 130-fold in 30 minutes, enabling us to support more than 2,500 orders per second. Now, again, when I first started working with them, they were just using relational databases, a standard kind of architecture. They went with some read replicas and things. Now they've got a much more advanced architecture where they're using DynamoDB, they're using caching, and they also have now using our Spot instances. So Spot instances are essentially our spare capacity that we give to you at a market demand price. And you can use them and bid for them at a certain price. And we also have a spot block where you can actually say, I need this for, say, 4 hours or 6 hours. So if you know your promotion is going to be at this period of time, you essentially say, can I get some of AWS spare capacity at a much cheaper price, sometimes only 10% of what the hourly rate is for on demand, and lock that in for the promotion. And these guys have now adopted that. So they're able to do that very, very quickly, scale up, use servers at a very low cost, and then be able to do the promotions for their tickets, which is mostly around concerts for pop singers and those types of things. But of course, on a daily basis, when they're not having the promotion, they bring all of that down, and it's a much simpler operation for just constant day-to-day business. And the flexibility that AWS provides is to give you this platform where you can scale immensely, but you can always bring it back to a much simpler and, of course, cheaper operation for day-to-day business when you're not doing these promotions. So I hope you've learnt the core concepts of what we consider to be large-scale promotions and events, what the main problems are that you have to look out for, some of the bad examples of what you don't want happening, and of course, what the architectures are and the stages are of what you can adopt to get to the point where you get large-scale operations for these types of promotions. Thank you.